Rebuilding Puerto Rico's Energy Grid by Timothy Kirby, Joe Rominger, and Michael Sherping. Recently, Puerto Rico was struck by a slew of hurricanes that destroyed most of its electrical infrastructure. As a result, less than 25% of its residents have access to electricity again. And as you can see, most of the electricity that has been returned is only to the most urban areas of the island. With no means of generating or transporting electricity to the majority of residents in Puerto Rico without power, immediate action needs to be taken. First and foremost, after withstanding the damages of Hurricane Maria, most of the roadways and other essential infrastructure have been destroyed. This makes the installation of any power source challenging because it is difficult to transport the materials and other resources to the installation site. Second, the geography of Puerto Rico makes transporting the electricity generated difficult because the mountains that reside in the center of the island block the most direct path from large coastal cities to another, with rough terrain where it is difficult to install high voltage lines. Lastly, Puerto Rico does not have the funds to pump into expensive, unreliable sources of power. Funding is likely to be used to support victims of the hurricanes. As a result, the energy sources selected need to have a reasonable cost and high reliability. For this reason, we're recommending wind, solar, and wave energy for the island, as well as the introduction of microgrids.
We believe that the best way to rebuild Puerto Rico's energy grid is through the use of microgrids. Puerto Rico's Governor Ricardo Rosselló stated he believed microgrids are the best solution, and we agree with him. The map shows the different grids we have made. Having smaller grids will allow for less power line construction and therefore less losses in the lines, as power will be generated closer to where it is being consumed. We took into account two main factors that help determine where the grids will be. The first being geography. The middle of Puerto Rico is covered by mountains and thus make it hard to run power lines across it. The second being population density, as we tried to make no one power grid control too much of the population. We made power grids that surround the most mountainous parts of Puerto Rico and then made the middle region its own grid. The middle gets its own grid because it is the least populous part of Puerto Rico, as well as the most mountainous, and thus the hardest for construction. The rebuilding process for this region will be slower due to geography, and by separating it, it will affect the least amount of people. Wind energy is going to be one of the main sources of renewable power for Puerto Rico. This is due to the abundant wind and space constraints. In class, we studied power cycles where the energy came from heat exchange powering the working fluid. For wind turbines, the working fluid is air that is powered by the wind. The wind spins the blades, which in turn spin the turbine, producing power. Wind power has the flexibility to operate with turbines both at sea and on land. This is a critical resource for Puerto Rico due to its vast amounts of coastline. Offshore turbines could be implemented around the island. The wind is strongest in the northeast, which will help supply energy to Puerto Rico's largest city, San Juan. Furthermore, the isolated middle grid receives lots of wind and can also use wind as a primary means of energy.
Wave energy is a form of ocean energy that utilizes the motion of the water's surface and the potential energy found in the elevation change of waves to produce electricity. Due to the huge amounts of water surrounding Puerto Rico, this resource has been shown to have extremely high potential for the island by the National Renewable Energy Laboratory and several researchers contracted through Puerto Rico's Energy Affairs Administration. To harness this form of energy, a floating machine called an attenuator can be placed on the water's surface. It resembles a snake with long cylindrical components attached at bending joints. The motion of the waves raise, lower, push, and pull the segments of the device, causing compression and expansion in the hydraulic pumps found inside the joints. The changing volume of the pumps is used to drive a working fluid through a hydraulic motor attached to a generator, creating the electricity. This form of energy is useful for regions 1, 2, and 5 because the north and western edges of Puerto Rico experience the largest waves and also have limited access to solar and wind energy. However, this form of energy does face financial and logistical challenges as it is a new technology and needs to be installed on a large scale to be effective.
There are two main types of solar energy, photovoltaic and concentrated solar power. Photovoltaic uses the incoming photon to hit a silicon composite inside the solar panel. These photons cause the displacement of electrons, creating current. While concentrated solar power uses mirrors to redirect the sun's rays into a concentrated source of heat of substance. Either this would be one large tower with a liquid inside of it, or smaller troughs with each individual mirror for the trough. This style can be used with our typical vapor power cycle. The incoming heat will act as a boiler heating up the working fluid. This will then travel through a turbine producing energy. The working fluid will then be sent through a condenser to cool it down, lastly sent through a pump and sent back up to the boiler. Either form would be a good investment for Puerto Rico because the large amounts of sunlight seen by the island, especially on the southern side. Many of the houses could have their own private photovoltaic on the roofs to power their homes, and if extra energy, they could sell it back to the grid. Larger companies or organizations could use open fields to build large photovoltaic and concentrated solar panel farms to collect a large amount of energy at once. These solar farms would be concentrated mostly on the bottom of grids 1 and 4. This has the highest amount of solar activity and could produce the greatest results, while smaller grids farther away from the coast could prioritize private photovoltaics designed on buildings and homes. However, the large challenge that Puerto Rico will face is the extreme high upfront cost to install them and the limited land. Solar energy is very expensive and takes a very long time to pay off the debts that it costs. This will be a large problem for Puerto Rico because it doesn't have the time to get funding in order to begin the long process because they need immediate results right now with their energy grid system down. And especially their current energy company has put the country into a large amount of debt, and it will take a long time to overcome that first before they can afford a full energy grid system. Puerto Rico is facing a variety of hardships and challenges that need immediate action to overcome. The first would be to split the country into a variety of smaller energy grids to prevent one storm from being able to break different sections of the grid, which loses large parts of the country's energy. Secondly, with the new grids, each area could focus on using different types of renewable energy to utilize the country's natural resources. Solar would be focused in grids 1 and 4 because of the high concentration of solar. Onshore wind would be in the high mountains of grids 3 and 5, while the offshore would be on 2, 5, and 6. Lastly, ocean energy would be focused on grids 1 and 2, which has the highest waves coming towards the island. However, even with all these great renewable energy designs, Puerto Rico still will have to use fossil fuels in many areas because of the extreme need of getting power back as soon as possible to the people.